Hello good day viewers. Into this tutorial we are going to see the elastic collision. So we are given a question which says that a 4 kilogram ball moving east of a speed of 5 meters per second strike of a 2 kilogram what ball at rest. Calculate the velocity of the two balls assuming a perfectively elastic collision. So you have to first understand that in elastic collision, momentum and kinetic energy are conserved. But why in inelastic collision, momentum is conserved, but why kinetic energy is not conserved? So for any elastic and inelastic, momentum must conserve. So therefore, let's say we have m1 v1 plus plus m2 v2, it is equals to m1 v1 prime plus plus m2 b2 b2 prime. So we have to figure out the data. The m1, which is equals to 4 kg, and therefore a ball moving at a speed which is a v1 which is equals to 5 meters per second, and strength which is the m2 which is 2 kg, and therefore our v2 which is which is 0, which is at rest. So therefore calculate the velocities of the two balls. So we are going to find the velocities of two balls. So what should I going to do next? The next thing that I'm going to do here is that I have to say the value of m. What will be the m1? M1 which is 4 multiplied by v1 which is 5 plus 0. Because m2 is this multiplied by 0, it will give me It will give me 0. So therefore this should now be equals to what is m1? M1 which is 4 multiplied by v1 prime, I'm looking for it, b1 prime plus m2 which is 2, and v2 prime, I'm looking for it. So this should now be 20, it is equals to 4 v1 prime plus 2 v2 prime. So let me call this equation equation 1. So I have to use the kinetic energy. So therefore v1 plus plus b1 prime, it is equals to v2 plus v2 prime, because kinetic energy is conserved in elastic collision. So let me say that what is the value of v1 which is 5 plus plus b1 prime, and therefore it will be equals to v2, the value of b2 which is 0, and therefore plus plus b2 b2 prime. So this is the same thing as saying v2 prime will remain as it is, and therefore this should now cross should now cross the equal sign. It will now be negative negative v1, and therefore it will be equals to it will be equals to 5. This is the same thing as saying minus v1 prime plus plus b2 prime, it is equals to 5. So let me call this as as my second equation, which is equation 2. So the next thing that I'm going to do, I have to say that minus 4 v1 prime plus plus 2 v2 prime, it is equals to Okay, this is not minus, it is positive. So therefore this is equals to 20. This is the same thing as putting it like this. So I have negative v1 prime plus plus b2 prime, which is equals to which is equals to 5. So let me multiply this by 4 so that I'm going to use the element. This is a simultaneous equation. If you can use the Cramer's rule, you can apply the Cramer's rule to find it. But if you can use the elimination method, you can use it. So let's use the elimination method by multiplying this by 4 so that this will become will become 4. So this should now become Let me write this down. I'll have 4 v1 prime plus plus 2 v2 prime, it is equals to 20. So this should now be minus 4 4 v1 prime plus plus b2 prime, which is equals to Okay, this should now become 4, and this again should now become 4 b2 prime, and this should now be equals to 20. I will say 4 plus minus this should now give me 0, and therefore this plus this I should now get 6 v2 prime. So this should now become 40. So this is the same thing as dividing both sides by the value of 6. 6 will cancel 6. So v2 prime, it is equals to 40 divided by the value of 6. So I'll get 6.66 So let me use this equation to find what the value of v1 prime. So by saying minus v1 prime plus what, plus b2 prime, it is equals to 5. But the value of v2 prime, which is 6.667, so minus b1 prime should now be equals to 5 minus, when this cross the equal sign, it will now be 6.667 minus what, minus b1 prime, it is equals to what, 5. So I should say 5 minus answer. So this should now be minus 1.667. If I divide both sides by minus 1, this will cancel this, will cancel this. So therefore, b1 prime, it is equals to 1.667. So this is all for this question. So, but from the beginning, we said that m1 v1 plus m2 v2, it is equals to what? m1 v1 prime plus m2 v2 prime. So this equation must be equals to this equation. So how can I prove it? I have the value of m, which is 4 multiplied by what, m1 and v1, which is equals to what, 5, plus this, the v2, which is 0. So therefore this will be 0, is equals to m1. What will be the value of m1? m1, which is 4 multiplied by what, 4 multiplied by b1 prime, this is 1.667. And therefore I have to say plus what, m2, the value of m2, which is 2 multiplied by what, multiplied by 6.66 what, 7. So this shall now be 20, which will be equals to, so this shall now be 6.66 what, 6.66 plus what, 2 multiplied by 6.667. So this shall now be equals to what, 13.332. So this plus 6.666, so it's the same thing as 20, which is equals to what, 20.02. So as you can see, this equation, it is equals to this equation. Whenever you solve it, you will find this is equals to what, this. There are some approximation that I didn't do. This is the same thing as 7. This is the same thing as 3. So therefore, all it is the same thing. It will give you what, 20, which is equals to 20, because there might be some errors here, but don't mind about the point, but this will give you the same. So for the second equation, for the kinetic, v1 plus what, v1 prime, it is equals to v2 plus what, plus v2 prime. What is the value of v1? b1, which is 5, plus what, b1 prime, which is 1.667, which will now be equals to the value of b2, which is 0. So 0 plus v2 prime should give me this 0.667. So as you can see, this must give me 6.667, and 5 multiplied by 6, if I add this, I will get 6.667. So this is proved. So this is all I have for you for what, for the elastic collision. But you have to take a look to these formulas. They are very important. This is for the momentum, and this is what? This is for the momentum, and this is for the kinetic. So don't forget to subscribe to this YouTube channel. Thanks you for watching.